All right, so today we're going to look at chapter 13, section 1, and we're going to talk about precipitation reactions. And the way we are going to be using precipitation reactions and the way that precipitation reactions are used in everyday life is actually to determine the presence of ions that we consider to be pollutants in our water. So that'll be directly related to our lab that we're going to use for this chapter. All right, so let's look at precipitation reactions. Now, some of what we're going to look at today should be a review of our discussion in Chapter 8, which was the chemical reactions chapter. So we should know that precipitation reactions are a type of double displacement reaction. So that's what we're going to be looking at. And we're going to be taking them one step further. We are going to get to a type of equation that's known as a net ionic equation. In other words, what ions are being used to make our precipitate. So we're going to look at two examples together in class. All right, so I'm going to show you the video. In the video, you're going to see two clear colorless solutions. One of them is strontium chloride. The other one is sodium sulfate. We know that in order for double displacement reactions to take place, you have to have two ionic compounds that are in solution. Okay, that way their ions can dance.
Oh, yeah. What's happening? Such a good feeling.
All right, so we can see in the video that we produced a white solid. It was turned a cloudy white color, so we've made a white precipitate. And we know that the way we can determine the precipitate is to use solubility rules. So we'll get to that here in just a second. Right. So we're going to write formulas for our substances first. So I have strontium chloride, solution, and we have sodium sulfate solution. And remember that in double displacement, our ions are dancing. So we should know that we can take our metals and they can switch partners. Now remember that when we go to the other side, we're again going to cross charges to make subscripts, to make new formulas. So strontium sulfate and the other substance we make is sodium chloride. All right, so here is where we would pull out our periodic tables and look at the chart of solubility rules. And when we do so, we could look up the sodium ion. And in the table, it's going to tell us that all sodium ions are soluble. So this means that the compound that contains the sodium ion is aqueous. And that has to mean the other substance is then our precipitate. So now we've given states of matter. And then the only thing left to do is to balance the equation. So hopefully, if you look at it, you need to see that we need to increase the numbers of sodium and chlorine to 2. So we're going to put a coefficient of 2 in front of NaCl. So there's my balanced chemical equation. Okay. So again, review of what we should know from chapter 8. Okay. The new equations we're going to learn to write, there are actually 2 of them. So the first one we're going to learn to write is called a total ionic equation. Okay. In a total ionic equation, everything that is aqueous is going to dissociate. Okay, so if I look, my strontium chloride is aqueous, my sodium sulfate is aqueous, and my sodium chloride is aqueous. We know from earlier in the chapter, dissociate means we're going to break them apart into their ions. Okay, so we do one substance at a time. So we're going to break apart our strontium chloride. Okay, so the cation, now this is called an ionic equation, so these have charges. So if we use the periodic table, strontium's charge is +2. And the states of matter here are aqueous also. All right, now notice that this chlorine has a subscript. So we know from writing dissociation equations earlier in the chapter that subscripts become coefficients. So you have 2 chloride ions. Again, the state of matter of the ion is the same as it was in the balanced chemical equation. And it's an ion, so you have to show me its charge. Okay. We're going to break apart our sodium sulfate. So we have a sodium ion, and the subscript was 2. So now we have 2 sodium ions here. Again, I know the charge from its location on the periodic table. Sulfate is a pure polyatomic ion, so we can look it up in our chart of polyatomic ion to see that it has a charge of -2. Now, your precipitate has a solid state of matter, which means it's not going to dissociate. So we're just going to rewrite it exactly as it is in the balanced chemical equation. All right, now there is one new piece here, is that this sodium chloride has a coefficient. Right. So the thing we want to remember is that coefficients belong to both ions in the chemical formula. So both of these ions are going to have a coefficient of 2. Okay. So I have 2 sodium ions, and I'm going to have 2 chloride ions. Oh, and I probably should have, I'll draw my arrow here to show you that these have broken apart into those ions. All right, so we go from a balanced equation to a total ionic equation. And then once we have our total ionic equation, we are going to identify spectator ions. Now, a spectator ion has to appear as an ion on both sides of the equation. So in other words, it'll be an ion on the reactant side, it'll be an ion on the product side. All right, so when I look at this, I can see that I have 2 sodium ions. Okay, now your spectator ions should match, they should be identical. Their coefficient should be identical. So if for some reason, when you get to the end, you don't have identical coefficients here, this is kind of a clue to tell you that you need to go back and double check your work. And then I can also identify that I have 2 chloride ions. Again, notice that they both have a coefficient of 2. All right, once I've identified my spectator ions, that brings us to the very last step, and that is to write our net ionic equation. Now, the net ionic equation is showing you the ions that are going to make up the precipitate. So here's the easiest way to do that. You're going to look at your total ionic equation and all of the species in that equation that are not circled, that are not the spectator ions, so they weren't a spectator to the formation of the precipitate, are going to become your net ionic equation. So we're just going to copy it. So I have strontium plus 2 aqueous. I have sulfate with a -2 charge, aqueous. And this produces strontium sulfate, which is my precipitate. And then again, once you've copied all of the species into your net ionic equation, it should be balanced. So again, if it's not, this is a hint so that you know that you've made an error somewhere in going from your balanced to your total ionic equation, possibly. So go back and double check your work. Okay, so this is the one I walked you through. The next part, though, we're going to do together. So let's start by looking at our reaction. So again, I'm going to show a video, and then at the end of the video, I want you to predict, using your solubility rules, what your precipitate was.
Adding colorless sodium hydroxide to blue copper 2 nitrate produces a light blue precipitate.
All right, so I'm going to ask the sub to pause the video here and give you a moment to use your solubility rules to come up with a possible precipitate for this reaction. And let me, before they pause the video, let me show you what your reactants were. So you had a light blue copper 2 nitrate solution, and you had a clear colorless sodium hydroxide solution. All right, so it would probably be best to write your formulas for your products and then look at those solubility rules. I'm going to ask the sub to pause the video here and give you a few moments, and then hit the resume button on the video and I will show you what your products are. So again, we have a double displacement reaction. So my metals are going to trade partners. When I trade partners, copper pairs up with hydroxide. So we're going to make copper 2 hydroxide. And sodium is going to pair up with nitrate, and we're going to make sodium nitrate. Now, maybe you didn't have to use those solubility rules because you know that blue is color of copper compounds. And so that must mean that copper 2 hydroxide is the precipitate and sodium nitrate is aqueous. All right, so I'm gonna go ahead and give coefficients here. So we needed to balance the nitrates, so we're gonna put a 2 here. And then we need to balance the sodium and the hydroxide ions, so we're gonna need to put a 2 there. All right, the next part of this, we're going to write our total ionic equation. So remember, when we're writing a total ionic equation, everything that is aqueous in your balanced chemical equation is going to dissociate. It's going to break apart into its ions. So again, I'm going to ask the sub to pause the video here and give you a few moments to write your own total ionic equation, and then resume the video so that you can correct or check your work. All right, let's look at this answer. So we have a copper ion with a +2 charge. And again, states of matter for the aqueous species are still going to be aqueous as their ions. Okay. This nitrate ion has a subscript, so it's now going to become a coefficient. You can look up the charge of nitrate in your table of polyatomic ions. Remember that coefficients are going to belong to both ions in the formula. So we're going to have 2 sodium ions, and we can determine sodium charge based upon location on the periodic table. And we have 2 hydroxide ions. Again, hydroxide we can look up on their chart of polyatomic ions. Remember that our precipitate, which is the insoluble solid, is not going to dissociate. So we're just going to rewrite it exactly as it appears in the balanced chemical equation. And this other product is always going to be aqueous, so we're going to break this apart into its ions. Again, we want to remember that coefficients belong to both ions in the equation. So I have 2 sodium ions, and we're going to have 2 nitrate ions. All right, that is the correct answer for that step of the equation. All right, so my viewpoint here is that I want to be able to tell that you understand how to go from a balanced equation to a total ionic and then to a net ionic. So I'm going to be giving you the reactants, but you should be able to write their formulas, and you should be able to predict products all from chapter 8. So if you're struggling, come see me so we can review content from chapter 8. All right. Our next step in this process is to identify spectator ions. Okay. So as a reminder, spectator ions appear as ions on both the reactant and product side, and they should match identical. They should have same coefficients, they should have same formulas, same charge, same states of matter. Right? So this is a way to double check your work as you're proceeding. Again, let's have the sub stop the video. And then when it looks like you're ready, I'll have them click resume and you can double check your work. Okay, so here's what we should have identified. You should notice that you have 2 sodium ions on the reactant and product side, and you also had 2 nitrate ions on the reactant and product side. All right, the last step in this process then is to write a net ionic equation. The net ionic equation is showing me the formation of a precipitate. So again, the way we determined how to figure this out was that all the species that were not circled in your total ionic equation are going to be rewritten to make your net ionic equation. So let's pause the video. Okay, so you should have had the time to write out your net ionic equation. So here's what you should have. You should have copper plus 2 aqueous plus 2 hydroxide ions aqueous forms your copper 2 hydroxide precipitate. Okay. Now again, as long as everything was correct when you made your total ionic equation, then you should have a balanced net ionic equation. All right, so these are our notes for the precipitation reaction. Your assignment is to do the precipitation reaction worksheet. It's practice. It's in Schoology under the upcoming events. It will be due Thursday morning at 7 a.m.